Right now, we need to write to animated plot in order to show the effectiveness of the CNN structure. Okay, and so at each state we will apply firstly the convolutional layer, after that pooling, after that the fully connected layer, and after that the output image. Okay, and so the import torch is added. Import torch and functional should be added. Import matplotlib pyplot splt. Okay. Import matplot patches as patches. Okay. And also import matplotlib animation line as animation, and from torch vision import transform. Okay, also we need to read the pil import the image library. Okay, numpy smp. So first of all, we need to ensure the new random variable for the kernel. Okay, at each time code is run. Okay, torch manual seed mp.random.randint 0 to 10,000. Okay, and so at each time if you run this code, the torch is set a new variable in order to what? In order to assign random values to the kernel function. Okay, after that the input parameters should be given in here. First of all, the padding, for example 5, and stride 5, and kernel size is equals to the 5 or 2 or 2. Okay, after that we need to give the pooling parameter setting pool kernel. This is the size of the matrix 3 times 3. Okay, 3, and pool stride also given in the 3. And after that we need to continue with the loading the image and pre-processing image. Okay. Image path should be given here, just like this one, the picture one JPEG. After that the image should be opened with the image open image path, and resize should be called as with the tuple 224. Okay, after that we need to convert the image to grayscale and tensor, and so the transform is utilized for this purpose. Transform is equals to the transforms dot compose. Compose is specific method to apply the specific purpose of the water operation, just like this one. For example, the transforms dot grayscale is a general operator in order to what? In order to convert the whole RGB codes into the what? Into the grayscale one. And so num output channels is equals to 1 because it's the grayscale 0 to 1. And also transforms to tensor should be called in here in order to convert the whole these grayscale values in order to what? In order to convert to tensor. And after that, this transform is built right now, and so the image tensor is given with what? The transform image. Okay, and so the shape of this matrix 1, 2 to 4, and 2 to 4. Okay, this is a 3-dimensional, and so the image tensor is equals to the what? Image tensor squeeze 0. Okay, and so now the shape is equals to what? 2 to 4 and 2 to 4. Okay, this is a 3D, but this is the 2D. In the matrix multiplication or the convolution operator, this is so important, okay? You need to ensure that everything on the size of the column and the row vector must be same. So, in order to apply the padding to the image, first of all, apply image padded image is equals to f pad specific function, which is defined in the Torch library, functional library. Image tensor is equals to the pad, and so the padding, and also we need to 4 times copy of these terms, okay, and also the mode constant, and also value is equals to the 0 for the for the values of the distance, okay, and also padded height and padded width should be assigned padded image dot shape, okay, because if we apply the padding for this case, for example 2 to 4, but we need to increase the size of the to 30 or 230, and so we need to apply the 4 dimension, right, left, up, down, with the constant values of the 0, okay. We need to get the general image formation based on these informations. And after that we need to define 2 random convolutional kernel, okay. Kernel 1 is equals to the torch and rand n. This is a specific function to generate the distributional data, and so kernel size should be given here. If you are using the to the 5, and so 5 times 5 random matrices, and also we need to give the kernel 2, okay. So we have 2 different kernels, and so we apply the on the image, and so we will take to the y output image, okay. So for this case, setup output tensor must be called in here for the convolutional kernels, okay. First of all, we need to calculate the out height dimension and out width dimension, because it's important. If we apply the sum dimension or the transformation based on this information, we need to give them automatically these properties based on the based on the 2D or 3D matrices, and so the padded height minus kernel size divided by integer value, the stride plus 1 is r to r condition, and also we need to give the width, okay, in here. And after that, if this is the r case, initialize convolutional output tensor in order to be filled to the with the values, but also we need to define as the nonce at the initial values, okay. Output 1 torch full is a specific function, and so the out height, out width, and float none. This is the this is the first dimension. In the second dimension is the same, okay. After that, we need to define the pooling function. But manually. So def pool manual can be defined with with the input tensor. This is the input parameter. Pool kernel should be given in here, and pool stride must be given in here, and so in height value, internal height value and internal width value should be assigned the input tensor dot shape. This is the shape parameters of these terms, okay. After that, pool out height, which is equals to in height pool kernel divided by integer pool stride plus 1. And so matrix dimensionality should be adjusted based on these informations, guys. Okay, it's so important. Otherwise we have the matrix error in the code running. And so the pooled data can be built towards full values, but in terms of the what, right now the height and weight and the initial value float cast none. Okay, that's the initial value. And after that, in order to fill this data for I in range of pool height, okay, up to pool height, and for j in range of pool width, okay. So window input tensor must be assigned with what? I times pool stride, because this is the step point, and I times pool stride plus pool kernel. Okay, this is the size. And after that, with the same idea, j times pool stride and up to what? J pool stride plus pool kernel. Okay, this is simple operation. And after that, if this is the case, and so if torch is none, this is a control for the what? For the window. Okay, is any returns in here, and so put ij, this is the specific index of these terms, okay, window, and so the float none should be assigned in here. After that, we need to give the what? The put ij is assigned window max. Okay, this returns the maximum values. And so this building technique is to what? Is returning to the max point for a given kernel size on this place. Okay. So this is a max pooling. In the average pooling, whole window must be assigned with the what? With these terms. After that, we need to give the what? The plot settings. In this case, we need to build the what? Animation plot, in order to understand to CNN structure in a real-time applications. Okay, so fig and axis plt subplot is 3 and fig size is equals to the what? 1812. So ax input is equals to the axis 0 0 and ax con, this is the first grade, and con 2 is assigned the ij values in here, this is the 2, and ax pool 1, and so 1 0 and pool 2, and so this is the 1 and 1, and x kernel 1 is 1 and 2. This is simple in this for subplot. Okay, and x2 is the what? 2 0. Okay, and also x original must be given in here with the axis of the 2 1, and ax summary should be given within this place. This is the axis of the whole the terms in here. Okay, so in the first place, plot static subplot should be given in here. Ax input and im show is assigned with the what? With the padded image numpy. Okay, and cmap is equals to the gray, and interpolation is equals to the none. Okay, padded image. Okay, and after that x input is set title must be assigned with the padded input image. Also ax input is ax input axis must be off. Okay, so add a red rectangle for animation in here. Rect is equals to the patches is a specific purpose of the what defining the some basic elements of the geometry rectangle, which is 0 and 0. Okay, and after that the kernel size should be given in here. This is the dimension of this one, and this is the dimension of this one, height and width, and line width is 2, and h color is equals to the red, and also face color is equals to the none. Okay, and so for this case we need to ax input at patches rect. Okay, so if I run this code right now, if we have an error, this returns to this one, but to rent in okay, rent int. We need to test the whole algorithm because it is going to do what is map. Okay, 92 map. Okay, and so this goes on with the same methods. And so in order to take or recover the time, I copy all of these terms in here just like this one. This is the basics of the what con1 con2 image in here, but in order to initialize empty pooling outputs, so pull out height is equals to the out height pull kernel divided by integer value pull stride plus 1. Okay, and also I copy all of these terms in here. This is the white. Okay, this is the white, and so the pool kernel should be given here and pool size, and so the pools 1 is assigned with what a torch full value of the what pool height and pool width, and also float none. Okay, and also this is the pool 2, and in order to take the or gain the time, I copy all of these terms in here just like this one. Okay, after that this is the same plot techniques for the what for the static graph, and so we need to have normalized kernel in here just like this one, k, and k mean, k max, which is given k dot mean value and k dot max value. This is returned to the what to coming to the kernel function, and so return to the normalized kernel k minus k mean divided by k max minus k mean, and sometimes k max and k mean may be equals, and so 1 e minus 8 should be given here for the error case. Okay, and also we need to give the another copying these terms. These terms is a standard term, normal scanner, image tensor numpy, and convolutional padding of the text should be given in here. Okay, so how can I define the convolutional process. Arkadaşlar bazı kodları kopyalamak zorunda kalıyorum çünkü çok kod var bugün yazacağımız. O yüzden bazı yerlerde gereksiz yerleri direkt açık bir şekilde hemen kopyalayıp bırakıyorum. Code which is equals to what? It's the lambda expression I comprehension, or in the C++ I in range 0 padded height minus kernel size plus 1, and also stride should be given in here. Okay, and also we need to give the same syntax in here, just like this one, for I, not now, J, and this is the what? The white. Okay, this is the limit or boundary condition for what? For our cases. And so if I run this code and then I will check the error, and so there's no error in here. Okay, after that, this is the what? The coordinates for the what? Convolutional operation for an I and J value with a padded height and white value. Okay, and def compute cone function should be given in here, the kernel I and J, this is the specific coordinates, and so the patch should be applied to the padded image, but in the what? I to I plus kernel size, right? This is the basic syntax for our case. And also J plus kernel size. After that, in order to apply the values of these terms, torch some patches must be multiplied with the kernel. This is the convolution, and so return the value of the item. This summation returns the convolution value of these two matrices. Okay, this is simple. After that, we need to define the def update function in here, whether related to frame. Okay, this is the animation function. So we need to give the detailed information about it. First of all, I and J should be taken from the coordinates with the frame. Okay, after that, we need to update the red rectangle in here. So rect set x, y, j, and I. Okay, after that, compute convolution. So the value 1 is equals to the what? Compute convol kernel 1 for a given coordinates I and j, and also kernel 2 I and j. Okay, because we have two convolution operator, two matrices, and so using the one image, original image, we can generate two different images based on the two different kernel. Okay, so after that, we need to map padded image to convolution output. Okay, output I is equals to I stride. Okay, and so j is equals to the j stride. Okay, and so the output 1 with an index of the what? The stride, the out I, out j. Okay, and so the value 1 should be assigned in here, and also value 2 should be assigned to this one. Okay, after that, we need to update convolutional image, but the output. First of all, im cone 1. This is the what? The image of the convolutional one, and set data should be updated with the what? The output 1 numpy. Okay, and after that, we need to give the valid one in terms of the output 1, and so we need to check the whole in this torch dot is none, output 1, and so we can remove the whole the non-values in here, and then if valid 1 null function is greater than 0, and so in con 1 set clim should be applied in here, valid.min, and also the item, and valid 1 max and item, it's related values. Okay, and also x con 1, this is the figure title, subplot title is the what f kernel 1 new line patch add, and this one, this is the so this is the same I think right now, and so we can couple of these things because the x1 is set it with this one. This is a simple iteration, just set title is assigned to the new values of the patch. Okay, and also the imcount set data should be assigned because we calculated the values of the convolutional rate. After that, the compute pooling outputs for current output, but the convolutional one. Okay, so pooled data should be filled, pool manual should be assigned with the what output 1, pool kernel should be given in here just like this one. Okay, and also pool stride should be given in here. This is the basic parameters to what to apply the max pooling on this image. And also this show huge set data property in here. In pool set data, pool numpy, non-control and null control max min iteration should be given in here. At the end of this code should be given to the what, to the return rect. Also in con 1, in con 2, in pool 1, in pool 2. Okay, so after that any should be created, animated line. Any is equals to the animation dot func animation function. Figure should be base, update is the update function, frames is assigned the LAN coordinates in here because we have this kind of LAN, and internal is a 5 millisecond with it false, and also repeat true. Okay, or repeat false. PLT tight layout should be given in here, and also in order to catch the error, mng plot get current fig manager and mng dot window dot state zoomed. Okay, this is the what, this is the bigger than to what, or the screen height and width is equalized to the what, to the mng, and so accept exception as e, and so the print couldn't maximize the figure window. Okay, and also e should be given in here. After that we need to plt show function in here. Okay, and so if we don't have any error in here, just see that. See, I'm sorry, this convolution is so small right now, and show the kernel size 25 and 220. Okay, and so this is maybe 20 and 20. It's bigger right now. Okay, see, at each case the red applied is created the convolutional pattern in here, just like this one. Okay, and so this is the what, this is the patch, this is the patch, and so the pooling kernel and pooling kernel is updated based on this information. But what about this one? We have I'm sorry, we have some error in here. Max build. Okay, pool kernel is none. I J okay, so there should be no ham. Okay, when is the one second here? No, it's not the case. We have some error in here in the code. And J kernel 1 rect kernel 1 kernel 2 value 2 out I J is right. Okay, output 1 I J value 2 value 1 and set data and
hocam I ile J'nin şeyini ters yazmış olabilirsiniz. X, Y ayarlamasını.
this plasma. Where is it?
168. Ha yok.
No. This is J and I. This is C. What the input set data. In here. What about this one? I'm sorry, guys. And so the pool kernel 3 and 3 ham. No, it's not the case. Okay. Okay. See, the problem is that if we apply the kernel size 25 and stride and padding, we don't have enough data to create the pool kernel with the rate of the 20 and 20. Okay, because we don't have any data in Turkish. Eğer bakın biz burada kernel size'ını 20 seçersek bu stride ve padding'i oluştururken buraya zaten yeterince matris boyutu kalmıyor. O yüzden 20'ye 20'lik yapmak istediğimizde zaten bu değeri bulamıyor. Aslında sorun burada başlıyor arkadaşlar. Temel sorun bu. Şimdi bakın şuraya geldik. Bir so interval of the 50 milliseconds. Okay, in the first place, just see that we have the what each pattern is compared with the what with the convolutional layer of these terms, and so the kernel 1 is convolved with this image based on the what this rectangle area. And so this image is generated. After that, this image is convolved with what the max pooling layer, just like this one. Okay, and so this creates us to the what to the pooling layer, pooling kernel 2 and convolutional 1 and convolutional 2. Okay, and so we can generate this image convolutional 1 output, this the convolutional 2 output. And so this convolutional 1 is converting to pooling layer kernel 1 and pooling layer kernel 2. Okay, but what about this? If this is the case, and so we can assign the padding is the what 5 and 25, and so 5 and 5 can be given in here. And so if I run this code, this is 5 milliseconds, which is given in here. And after that, see, the patch is what is slowing right now. This kernel 1 is assigned with the what with this image. Okay, And so this convolved at each pattern and generated these values. And after that, if we have the data, the pooling kernel is assigned, which is given in here. 5 and 5 is kerneled and convolved with this one, and so maximum values is obtained. See? After the patch 24, 50, just see that 55, and so 60, and 65, and 70, right? Because, and I'm sorry, in the animated line, just see that the convolutional pattern at each case convolved each pattern based on the what? Based on this image. And right now, see that this image is what is similar to this one, but this is a different pattern. Okay? Şimdi arkadaşlar biraz da Türkçe anlatayım bunu. Anladınız mı bilmiyorum. Bakın şimdi bu adama biz convolve ediyoruz burada. Convolution uyguluyoruz. Şu kırmızı matrisin içerisine her zaman için şu kernel ile bunu yapmaya çalışıyoruz. Bakın şimdi burada bir tane resim oluştu ama burada farklı bir resim oluştu. Gördünüz mü? Bir tane resimdeki görüntüyü iki tane resim yaptık. Sonra gittik bu görüntüyle de yetinmedik. Sonra dedik ki burada bir pooling uygulayalım. Bu pooling'de bunu gitsin uygulasın dedik. Anlatabildim mi buraya? Yani aslında bir tane resimden birden fazla resim çıkardık. Sorunuz var mı? Türkçe'de sorabilirsiniz bu arada. Yazıyla yazın ama. Yani convolutional neural network bu şekilde çalışıyor arkadaşlar. Şimdi bakın mesela. Şuraya 1 yapalım. Yani çok hızlı yapsın. Yani şey yapacağız. 5 3 and so the 2 okay. So if I run this code, just see that this red rectangle is so small right now, but the detailed image is assigned right now. Okay, this is so small, but this is the highly detailed image. But at every case, we don't need every detail of this image in order to what? In order to find out this head. Okay. See that the kernel 5 times 5 matrix, 5 times 5 matrix, and so we can generate our basic building based on the what? These informations. Okay. Any question? I will send this code to you guys, and so each code can be reanalyzed based on your perspective. But just see that we have the convolutional layer 1, convolutional layer 2, pooling 1, pooling 2, and so we can generate what? The one image is given in here, 2, 3, 4, and 5. We multiply horizontal and vertical directional process or the data into the what? Into the 5 different image. And so this is useful to what? To enrich our data set based on this convolutional or the pooling transform in the convolutional layer. And so this is a so huge advantage to what? To analyze vertical and the horizontal axis information with the same pattern. Okay. Anladınız mı arkadaşlar? Sorunuz var mı? Bakın mesela şimdi hassasiyeti arttırdım ya. Hassasiyeti arttırınca gördünüz mü? Sağ tarafta mesela burada mor oluşan şey sol tarafta sarı oluştu mesela. Bak tamamen random bir şeyin içerisinde. Ve bakın şimdi bu kerneller şu an rastgele. Ama düşünün. Biz bunları eğitebilseydik nasıl olurdu? Yani şu kerneli öyle ayarlasaydık ki buradaki bütün resmi silsin ama sadece bir kafa kalsın. Bu müthiş bir şey olmaz mıydı arkadaşlar? Aslında convolutional neural network bunu yapıyor. Mesela biz bu dayının sigara içip içmediğini tespit edebiliriz. Nereden edebiliriz? Direkt bu filtreyi öyle bir filtre çıkarırım ki ben burada eğittiririm ki bu filtreyi siz buraya koyduğunuzda sadece bir adamın ağzındaki sigarayı yakalar arkadaşlar. Gençler bu bitmeyecek ya. Ben şunu biraz daha hızlandırayım. Durun. Hadi bu 25 olsun şöyle. Hızlı hızlı yapsın yani. Ne yavaş oldu. 10 olsun. 10 olsun. Bu parametrelerle oynayın arkadaşlar kendiniz bilgisayarda yaparken. Bunlarla oynadıkça daha iyi çalışıp çalışmıyor. Yani aslında bunu daha iyi öğreneceksiniz arkadaşlar. Bu padding nedir, stride nedir? Bunlara dair çok ciddi ve net bir bilginiz olacak. Okay. Please rerun this code in your computer, guys. Okay. And so this are generated images based on the filter applications. So in the last code were tree and full cnn.py based on the what? Based on the Pytorch. Okay. And so the import torch, or I should copy because I have no time to build everything, but the function left optim torch vision and transform is the transform, but the data loader should be given in here because if we are using any data set in our Pytorch, we need to import this data loader what's given in here. Okay. And so how can we build the model, CNN model, using Pytorch? Class cfar10 CNN, okay, nn module. This is what the inheritance properties of this term, and so def init should be given in here, just like this one, the arguments not using here, and this is the cfar10 CNN, and also we need to give the self, and also this parameter is not used. Okay. And so first of all the self con1 should be defined in here. Okay guys, con. And so nn con2d is a standard function with the input and the output channels 3 to 46, and which means that we have the RGB code red, green, blue 3, and so 64 filter is defined in here with the kernel size of 3 and padding of the 1. Okay. And after that convolutional 2, and so the 64 filter and 64 filter is used in here, and so we have in the first layer 64 filter to 64 output, and so we have the 64 filter in here, and so 3, this is the input shape 3, 32 and 32 right now. Okay. And after that the self pool 1, which is equals to nn max pool 2d should be given in here with the kernel size of the 4. Okay. Reduces the dimension 32 to 8. Okay. And also after that self dropout should be applied in here, dropout 1, and then dropout 0.05 in order to stabilize the R network. So this is the first layer, and so after that we need to write the second convolutional layer. Okay. And so this is the count 3, this is the count 4, pull 2, and drop out 2. Okay. But right now the 64 is the beginning, and 48 filter, and 48 filter to 48 filter, and kernel size is 3. This is reducing to the what? The 8 to 3 or 2 floor division is applied, and self drop out is the same. And after that, we need to apply also another convolutional layer. And this is the what? The 5 and 6 and pull 3 and drop out 3. Okay. And so this is the what? And I'm sorry, this is the 48 right now. And this is 48 is input, and 32 and 32 and 32. Kernel size padding is equals to this one, and after that kernel size 2 and 2 2 1. Okay. So after that we need to define the fully connected layer. Right now, self flatten is defined as nn flatten to fit the fully connected layer. Okay, and so self fc1 is equals to the nn linear 32, because we have the 32 output in here in terms of the what? In terms of the 1. Okay, and so 60 should be given in here, and so dropout 4 is applied just like this one, and self fc2 right now it's the 60 to 30, and also dropout must be assigned in here 5 0 to 5, and so the self fc3, this is a 3 layer hidden layer, should be given in here 30 to 10, because we have the 10 classes in the CFAR dataset. I will show the CFAR dataset, guys. Okay. After that, just remember the previous lesson. We can define the forward self x pattern in here, and so collect the intermediate activations in here, activations, which is equals to the empty block, and so for the block 1, x is equals to the f relu is applied self con1 pattern x, right? And after that, the activations pattern append x, because we want to add or store the activation patterns based on this information, and so each layer can be observable based on this information. Okay, and also x con 2 should be given in here, and also x is assigned to self pool is assigned in here just like this one, pool 1. Okay, and also x equals to the self dropout is to what? X to x. Okay, and also activation is added. Okay, so the block 2, this is the same idea in here, and so this is the cone 3 and 4, right? And so pull 2 and drop out 2, right? And so the same idea is added in here, block 3, and so 5 and 6, 5 and 6, and pull 3 x 3. Okay, and after that in here the flatten and fc layers can be given. X self flatten should be applied to the x, and also should be given here, and x f relu hard nonlinearity is applied to self fc1 x. Okay, and activation should be given here, and x self drop out, but for x should be applied, and also should be given here just like this one, and x f relu self fc2 x activation append. And so this must be copied right now just like this one, no, x is equals to the self drop out 5x, and activation appends should be added in here. And so after that, x is equals to the self f3 x, and also return I'm sorry, append activation should be right, and return x and activation. These are full model to what to define or classify the R cipher dataset. Okay, and so how we can use that? That main function should be given here. And so just before the lesson, transform is equals to the transforms. Compose is a standard method in here, just like this one, and so transform to tensor should be called in here. Okay, after that, loading the cipher dataset. Okay, this is the pre-trained, or this is the public dataset to containing to do what airplane, automobile, bird, cat, deer, dog, and something like that. Okay, and so we can obtain this dataset from the Torch Vision dataset, the cipher 10. Okay, and so the root is equals to the what dot data. Okay, and so data train is true, and also download true if it's not, and transform is transform. Okay, because this transform can be passed into the this one. Okay, and also with the same way we can define to the what test dataset, test, and shows for data and train. This one is false, and that one true, and transform. Okay, and also train loader should be built with the data loader. This is useful because the train set can easily be split the batch size using this one. This is the shuffle true. Okay, and also this is the test loader in order to test our algorithm based on accuracy value. Test set batch size this one, but this is false. Okay, so we need to give the class name, and so we don't have much time right now, guys, so I can copy all of this code in here because we have 7 minutes. Okay, and so if I run this code, I'm sorry, I will say this code, but you must use this one. And so okay, this is downloading this data right now. I'm sorry. And so in this case we need to build the model and loss and optimizer right now. Optimizer device should be assigned the torch device Judah. Okay, and so model should be assigned to cipher 10 CNN. This our model is built with the what, with this class. Okay, to device, because in this device this is the Judah core. If you don't have the Judah core, and so you should assign the CPU core. Okay, and criterion should be assigned with what, the NN cross entropy loss, because it's a classification problem. Okay, and so the optimizers, which is equals to what, the optim Adam, just this one. Okay, and so the model parameters should be given in here. Learning rate 0.001, and so the betas parameter, adaptive moment estimation 0.9 to 0.999. Okay, And so num epoch is assigned to 5, and so train accuracy history is given by this one, and while accuracy history is created with this one. And so for epoch in range num epoch, this is the 5 epoch, and so we need to open the model train function. Okay, and after that running loss should be defining here 0.0, and total is 0, and correct is 0. Okay, because this is the classification problem. And so just see that this is the CFAR image. Okay, horse, deer, bird, truck, and something like that. And so we have 4 minutes. I'm sorry, but I need to copy all of these algorithms right now. And so you need to check this algorithm later. Okay, and so I need to show all the values of these terms. Okay, num epochs, train loader is not defined. Okay, I have 3 minutes, and so after that is fun. And so we need to classify these algorithms based on this information. And so our training phase is run right now. Okay, in here just see that the accuracy of the loss model, which is given here 0, image is fed into the what the model outputs, and the labels and the outputs is compared in here, and so the predicted max values is assigned, and so the correct and the total label size is to what is compared. After that the validation phase is performed, and so just see that this is the 0.60 in the validation rate. And so after that, if we train this network, it's going to the what? Going to the increase. Okay. Arkadaşlar şimdi 2 dakika kaldı. Kayıt kapanabilir. Ben bu kodları size atacağım. Kodları yine incelersiniz siz. Ama şöyle bir şey yapalım buraya en azından. Şöyle yapayım. 10 diyeyim şuraya mesela, atıyorum 0.1 olsun. En azından atabildiğimiz kadar run atalım burada. Bakın en son validation accuracy 66'ya çıktı mesela burada. Eğer bunun hiperparametrelerini oynarsanız, şuradaki aslında hiper optimizasyon parametrelerini değiştirirseniz kesinlikle burada daha iyi sonuçlar alırsınız. Ya da onu hep o mesela uzatırsanız daha fazla yaparsınız. Ya da train, test, dataset'i bölerseniz bir şeyler yaparsanız daha farklı sonuçlar alacaksınız. If design your dataset which is given here, and so you can set the different properties of your network, and then maybe you can reach or obtain the values, the more optimized values. Just see that this is not appropriate for this case, but for example this is 0.1, 0.001 is most appropriate for this case. Okay. Son dakika arkadaşlar, kapanırsa kapanabilir, bilginiz olsun. Şimdiden görüşmek üzere. Yani şu an kayıt bitiyor mu bilmiyorum ama ben bu kodları size yollayacağım. Orada bu CPU'yu çalıştırdığı için şöyle bir şey oluyor arkadaşlar. %24. Bakın şurada %100 de çalışıyor çünkü çok ciddi bir şeyi var. Tüketim gücü var CPU'nun. Böyle bir sorun var. Şu an benim bilgisayar yanıyor. Öyle diyeyim size yani. Ama işlemleri çok hızlaştırıyor çünkü veri seti çok yüksek. Data set is so high, and so it's not closed. So the dataset is high dimensional data, and then this dataset is or are processed with the what? With the based on the GPU power, not the CPU one. CPU is more useless to train this network structure. Okay. See, the validation accuracy is going to the what? Is going to the 100, but slowly. Okay. And so you need to optimize your network to what? To design your hyperparameters in here. For example, this may be changed, or this may be changed, or dropout rate may be changed, or kernel size may be changed in this case. Okay. So that's all.